One of the questions I got was on number 1 from the parametric worksheet. Okay, so I was just going to run through how those solutions were attained. Okay, so we have 2 points here, and it's going to be 5 units apart, and to get from one point to the other, right? One of the directions I could go down. Remember, it's just along this line here, so it didn't tell us exactly if we're going down or going in the other direction along the line. Just give us the equation of the line. So I'm just going to assume for the first one that it went down. Okay, I could make that negative, but it doesn't really matter because I'm about to do Pythagorean theorem, right, for this right triangle. And then I'll have 25 equals 10a squared. I'll divide both sides by 10. And so I'll have a squared equals 5 over 2. So a equals plus or minus the square root of 5 halves there. And that's gonna account for which direction I'm going to be going in. Am I going to be going down this way or up the other way? So we'll really just keep it as positive for now. Right? We can leave it as that. We can rationalize if we want. It doesn't really matter for ourselves exactly how we write it. You can see the solutions at one way to do it. Here's just another way to do it here. So we have our a value there. Okay, so that tells us basically what our horizontal and our vertical distance traveled is going to be. Okay, so let me take a look at this. What are the coordinates of all possible locations of the object at t equals 1.5? So if we were moving this direction here, right, for ourselves, okay, we can get one answer and we're going to get a second answer from the other one. So let's try to think about our x and our y equations for ourselves. Okay, so if we're thinking about our x equation, our x is starting at -2 and our y is starting at 11. Okay, and then we can see as we do this, right, because of the speed there, we're going to have to figure out how much or little to add to both of those as we go there. Okay, so this 5 was not the x component or the y component, that was just our speed there, right? We've just figured out what our x component is. Our x component there being 1 times the a value there of root 5 over 2t. Okay, and we can see what our y component is, right? That our y component here, in this case, it's going down for ourselves, so I can follow that line, so I'll make that a minus there, right? 3 root 5 halves t for ourselves. Okay, so this is just telling us how much we moved, right? As we go, if we're assuming that we move down this way, right, then this is the equation we'd have for ourselves. If moving right and down. Okay, if we're going to be going along the line in this direction here, whoops, in that direction there, right, then what's going to be happening? Okay, so the other equation is going to be -2 for our starting point, and then we're going to go to the left, and then we're going to go up. Okay, so those are our 2 equations, and that's why there's going to be 2 answers. So when we plug in the 1.5 there, we'll get our 2 answers. And on the answer key, you talk about the exact form. They rounded it. That's just, I stole this answer key, so the person who did this was not, got a little mixed up with the exact first approximate. Right? There's an exact x value. If we're getting the exact location, there's the exact x value, and then here's the exact y value. Let's see, it's going to be minus 4.5 root 5 over t. Okay, so there's one point. The other point being, if I had -2 minus 1.5 root 5 halves, and then 11 plus 4.5 root 5 halves. We could have written this as one answer where we put this plus minus and this is minus plus, and then we would have had, people could see, okay, the top ones are 1 and the bottom ones are their second one. Okay, hope that makes sense.